The universe is vast, mysterious, and absolutely terrifying when you really think about it. Most people go about their daily lives blissfully unaware of the cosmic horrors lurking beyond our tiny blue planet. But today, we're diving deep into the disturbing universe iceberg, where each layer reveals increasingly unsettling truths about the reality we inhabit. You've probably seen iceberg charts before. They start with familiar, surface-level information at the top, then plunge into progressively darker and more obscure knowledge as you descend. This particular iceberg will take you from the comforting basics of astronomy that you learned in school, all the way down to mind-bending theories that will make you question the very nature of existence itself. Fair warning, by the time we reach the bottom of this cosmic rabbit hole, you might find yourself staring at the night sky with a completely different perspective. Some of these concepts are so fundamentally disturbing that they've kept physicists awake at night, questioning everything they thought they knew about reality. So buckle up, because we're about to embark on a journey through the most unsettling aspects of our universe, starting with the seemingly innocent stuff you think you already know, and ending with revelations that might just break your brain. Let's begin at the surface level, where most people feel comfortable. Here we find the familiar celestial objects that have fascinated humanity for millennia. Stars, those brilliant points of light scattered across our night sky, seem peaceful and beautiful from our earthbound perspective. But the reality is far more violent than most people realize. Every star you see is essentially a massive nuclear furnace, constantly exploding in a barely controlled fusion reaction. The sun alone converts over 4 million tons of matter into pure energy every single second. Think about that for a moment. 4 million tons of matter, completely annihilated and transformed into the light and heat that keeps us alive. It's a cosmic engine of destruction so powerful that a single second of its output could supply all of humanity's energy needs for hundreds of thousands of years. But stars don't just burn quietly forever. They live, they age, and eventually they die in ways that are absolutely catastrophic. When massive stars reach the end of their lives, they don't simply fade away like a candle. Instead, they explode with such incredible violence that a single stellar death can outshine an entire galaxy containing hundreds of billions of other stars. These stellar explosions, called supernovae, are so energetic that they can be seen from billions of light years away. Just one supernova releases more energy in a few seconds than our sun will produce in its entire 10 billion year lifetime. The explosion is so intense that it creates elements heavier than iron by literally crushing atomic nuclei together under unimaginable pressure and heat. And here's what's truly unsettling about this. Every heavy element in your body, the calcium in your bones, the iron in your blood, the oxygen you breathe, was forged in the nuclear furnace of a dying star and scattered across space in one of these cosmic explosions. You are quite literally made of stardust, born from stellar violence that occurred billions of years before Earth even existed. Moving deeper into our iceberg, we encounter galaxies. These aren't just pretty spiral patterns in space. They're massive gravitational prisons containing hundreds of billions of stars, all held together by something far more sinister than most people realize. At the heart of nearly every galaxy lurks a supermassive black hole, an object so dense and powerful that it warps space and time itself. Our own Milky Way galaxy is being slowly consumed by one of these monsters. Sagittarius A star, the supermassive black hole at our galactic center, weighs as much as 4 million of our suns, compressed into a region smaller than the orbit of Mercury. It's constantly feeding, tearing apart stars and gas clouds that venture too close, heating the material to billions of degrees as it spirals inward to its doom. But black holes aren't just cosmic vacuum cleaners. They're reality-breaking objects that demonstrate just how fragile our understanding of physics really is. According to Einstein's general relativity, the center of a black hole contains what's called a gravitational singularity, a point where space and time themselves break down. Matter is compressed to infinite density, and the normal laws of physics simply stop working. This brings us to one of the most disturbing aspects of black holes, something that sounds almost comical but represents a genuine threat to anyone who might encounter one. It's called spaghettification, and it's exactly what it sounds like. As you fall toward a black hole, the gravitational pull on your feet becomes significantly stronger than the pull on your head, since your feet are closer to the black hole. This difference in gravitational force stretches your body like a piece of spaghetti, pulling you longer and thinner until you're torn apart at the molecular level. But that's not even the most disturbing part. Due to the way gravity affects time, an outside observer watching you fall into a black hole would see something even more horrifying. From their perspective, time slows down for you as you approach the event horizon. They would watch you stretch and redshift, your image becoming dimmer and redder, but never quite disappearing. In a sense, your final moments would be frozen in time forever, preserved on the event horizon, like a cosmic photograph of your destruction. The Big Bang Theory itself reveals disturbing truths about the nature of reality. Most people think of it as a massive explosion that happens somewhere in space, but that's not accurate at all. The Big Bang wasn't an explosion in space, it was an explosion of space itself. The entire universe, everything that exists, emerged from a state of infinite density and temperature called a singularity. But here's what's truly unsettling about this. If we trace the universe backward in time, we reach a point where all the matter and energy that would eventually become galaxies, stars, planets, and people was compressed into a region smaller than a single atom. Everything you see around you, the vast cosmos stretching billions of light years in every direction, once existed in a space so small you couldn't see it with the most powerful microscope ever built. And we have absolutely no idea what caused it. The Big Bang Theory explains what happened after the initial expansion began, but it tells us nothing about why it started or what, if anything, existed before. We're essentially living in the aftermath of an event so incomprehensibly violent and mysterious that it created space and time themselves. The expansion of the universe adds another layer of cosmic dread. Space itself is stretching, carrying galaxies away from each other at ever-increasing speeds. This isn't like objects moving through space, it's space itself getting bigger. And here's the truly disturbing part. This expansion is accelerating. There are regions of the universe that are moving away from us faster than the speed of light. Not because anything is actually traveling faster than light, but because the space between us and those regions is expanding so rapidly that light from those areas will never reach us. There are entire cosmic neighborhoods that we are permanently cut off from, hidden behind what cosmologists call the cosmic event horizon. This means there are potentially trillions of galaxies, each containing billions of stars and possibly countless worlds, that we will never see, never know about, and never contact, no matter how advanced our technology becomes. They exist in our universe, but they might as well be in a completely separate reality. We are cosmically isolated, trapped in an ever-shrinking bubble of observable space while the rest of the universe races away from us into darkness. The atoms that make up everything around you, including your own body, reveal their own disturbing secrets when examined closely. What seems solid and real is actually mostly empty space. If an atom was scaled up to the size of a football stadium, the nucleus would be about the size of a marble sitting at the center, and the electrons would be tiny specks orbiting somewhere in the upper bleachers. This means that everything you touch, everything you see, is essentially empty space held together by invisible forces. The feeling of solidity is an illusion created by electromagnetic fields repelling each other. When you sit in a chair, you're not actually touching it. The electrons in your body are pushing against the electrons in the chair, creating the sensation of contact, but there's always a tiny gap between them. But the truly disturbing part comes when we look even deeper. Those protons and neutrons in the atomic nucleus aren't fundamental particles either. They're made of even smaller components called quarks, held together by forces so strong that we can never observe a quark in isolation. Try to pull quarks apart, and the energy you put in actually creates new quarks, making the problem worse rather than solving it. And quarks themselves might not be the end of the story. Some theories suggest they could be made of even smaller components, perhaps vibrating strings of energy existing in dimensions we can't perceive. Every time we think we've found the fundamental building blocks of reality, we discover that they're made of something even more mysterious and incomprehensible. This journey into the heart of matter reveals a disturbing truth about the nature of reality itself. The deeper we look, the more we realize that everything we think of as solid, permanent, and real is actually a temporary arrangement of energy and forces that we barely understand. We're living in a universe where the most basic question, what is everything made of, still doesn't have a complete answer. As we prepare to dive even deeper into this cosmic iceberg, remember that we've only just begun to scratch the surface of the universe's most disturbing secrets. The familiar concepts of stars, galaxies, and atoms that we've just explored will seem comforting compared to what lies ahead. In the next layer of our journey, we'll encounter phenomena that challenge not just our understanding of physics, but our very perception of reality itself. We'll explore objects so dense that a teaspoon of their material would weigh as much as a mountain, radiation bursts so powerful they could sterilize entire sections of the galaxy, and particles that seem to know they're being watched. The universe is far stranger and more terrifying than most people ever imagine, and we've only just begun to explore its darkest secrets. The next layer of our cosmic horror story introduces us to objects so bizarre that they seem like they belong in science fiction rather than reality. But these nightmare-fueled creations are very real, and they're scattered throughout our universe, like cosmic landmines, waiting to remind us just how hostile space really is. Let's start with neutron stars, objects so impossibly dense that they redefine what we think matter can become. When a massive star dies in a supernova explosion, sometimes the core doesn't form a black hole. Instead, it gets crushed into something even more disturbing in its own way. Imagine taking the mass of our entire sun and compressing it into a sphere only about 12 miles across. The result is a neutron star, where matter becomes so dense that a single teaspoon would weigh roughly 6 billion tons. But the density isn't even the most unsettling part. These stellar corpses spin at absolutely mind-bending speeds. The fastest known neutron star rotates over 700 times per second. Picture this: an object with the mass of the sun, compressed to the size of a small city, spinning so fast that its surface moves at nearly a quarter of the speed of light. If you could somehow stand on the surface of such an object, you would be travelling at 70,000 kilometers per second. The physics of neutron stars becomes even more disturbing when you consider what matter actually becomes under such extreme conditions. The normal atoms that make up everything you know get crushed so completely that electrons are forced to merge with protons, creating a soup of neutrons packed together tighter than anything else in the universe except black holes. Scientists have discovered that the inner crust of these objects forms structures so bizarre they've been given names like nuclear pasta, where matter arranges itself into shapes resembling lasagna sheets and spaghetti strands. Some neutron stars become even more terrifying when they turn into pulsars. These are neutron stars that emit beams of radiation from their magnetic poles, sweeping across space like cosmic lighthouses. But these aren't gentle beams of light. They're concentrated streams of deadly radiation that could sterilize any planet unlucky enough to be in their path. The magnetic fields around pulsars are trillions of times stronger than Earth's magnetic field, so powerful they could rip the iron from your blood if you got too close. Moving deeper into the abyss of cosmic terror, we encounter gamma-ray bursts, quite possibly the most violent events in the universe since the Big Bang itself. These are explosions so energetic that they make supernova look like firecrackers. In just a few seconds, a gamma-ray burst releases more energy than our sun will produce in its entire 10 billion year lifetime. What makes gamma-ray bursts particularly disturbing is their unpredictability and their reach. They can occur anywhere in the universe with virtually no warning, and when they do, they send out focused beams of the most deadly radiation imaginable. If a gamma-ray burst occurred within our own galaxy, and one of those beams pointed toward Earth, it could strip away our ozone layer in seconds, exposing all life to lethal solar radiation. The truly terrifying part is that we would have no advance warning. The first sign of a gamma-ray burst would be the burst itself, arriving at the speed of light, along with the deadly radiation. There would be no time to prepare, no time to take shelter. One moment, everything would be normal, and the next moment, our planet could be bathed in radiation levels that would make Chernobyl look like a mild sunburn. Scientists estimate that gamma-ray bursts occur somewhere in the observable universe about once per day. That's roughly 365 cosmic explosions every year, each one capable of sterilizing planets across vast distances. We exist in a universe where weapons of unimaginable destruction are constantly going off, and our continued survival depends partly on the cosmic luck that none of them have pointed in our direction. But perhaps nothing in the universe is as fundamentally disturbing as the realm of quantum mechanics, where the very foundations of reality begin to crumble under close examination. At the scale of atoms and subatomic particles, the universe operates according to rules so bizarre that even the scientists who study them admit they don't really understand what's happening. The famous double-slit experiment reveals just how wrong our intuitions about reality really are. When scientists fire individual particles at a screen with two slits cut in it, something impossible happens. Each particle somehow goes through both slits simultaneously, creating an interference pattern that should only be possible if the particle was in two places at once. But here's where it gets truly disturbing. The moment someone tries to observe which slit the particle goes through, it suddenly behaves normally, going through only one slit or the other. This suggests that the act of observation itself changes reality at the most fundamental level. Particles exist in multiple states simultaneously until someone looks at them, at which point they collapse into a single definite state. It's as if the universe exists in a state of cosmic uncertainty until consciousness intervenes to force it to make a decision. The implications of this are deeply unsettling. If particles can exist in multiple states simultaneously, and if observation collapses these possibilities into reality, what does this say about the nature of existence itself? Some interpretations suggest that every quantum measurement creates new parallel universes, meaning that reality is constantly branching into countless alternate timelines. Others propose that consciousness plays a fundamental role in shaping reality, which raises disturbing questions about what reality even means when no one is looking. The uncertainty principle adds another layer of cosmic dread to quantum mechanics. It states that you cannot simultaneously know both the exact position and exact momentum of any particle. This isn't just a limitation of our measuring instruments, it's a fundamental property of reality itself. The universe appears to be built on a foundation of irreducible uncertainty, where precise knowledge becomes impossible, not because of technical limitations, but because precision itself doesn't exist at the quantum level. This uncertainty extends to the very fabric of space and time. Even in what we consider empty space, quantum fluctuations are constantly creating pairs of particles and antiparticles that appear from nothing and annihilate each other almost instantly. The vacuum of space isn't actually empty. It's seething with virtual particles popping in and out of existence so quickly that we can barely detect them. These quantum fluctuations have real consequences for the universe. Near black holes they create Hawking radiation, where one particle from a virtual pair falls into the black hole while the other escapes, causing the black hole to slowly evaporate. Over unimaginably long periods of time, even the most massive black holes will eventually disappear completely, leaving behind only the faintest whisper of radiation. The concept of antimatter adds yet another disturbing dimension to our understanding of reality. For every type of particle that exists, there's a corresponding antiparticle with opposite properties. When matter and antimatter meet, they annihilate each other completely, converting their entire mass into pure energy with perfect efficiency. This raises a terrifying question. If the Big Bang created equal amounts of matter and antimatter, why does our universe seem to be made almost entirely of matter? Where did all the antimatter go? The fact that we exist at all suggests that something caused a tiny imbalance between matter and antimatter in the early universe. If that imbalance had been even slightly different, or if it hadn't occurred at all, the universe would have been filled with nothing but radiation, with no atoms, no stars, no planets, and no life. We owe our existence to what appears to be a cosmic accident, a minute asymmetry that allowed matter to win out over antimatter by the tiniest of margins. But this also means that vast quantities of antimatter could still exist somewhere in the universe, separated from matter by cosmic distances. If matter and antimatter regions ever came into contact, the resulting annihilation would release energy levels that make nuclear weapons look like toys. The study of cosmic rays reveals another unsettling truth about our place in the universe. High-energy particles are constantly bombarding Earth from deep space, some carrying energies so extreme that we don't understand how they could have been created. The most energetic cosmic rays hit our atmosphere with more energy than the fastest particles we can create in our most powerful accelerators. These ultra-high energy cosmic rays pose a mystery that borders on the disturbing. They carry so much energy that they shouldn't be able to travel very far through space without losing energy to interactions with background radiation. Yet somehow they reach us from distances that should be impossible. Either our understanding of physics is fundamentally wrong, or there are cosmic accelerators out there far more powerful than anything we've imagined. Some of these particles carry energies equivalent to a baseball traveling at 60 miles per hour, all concentrated in a single subatomic particle. When they hit our atmosphere, they create cascades of secondary particles that rain down over areas the size of entire cities. We're constantly being bombarded by these cosmic bullets, most of which pass harmlessly through our bodies, but some of which could potentially cause genetic damage or even influence the evolution of life on Earth. The dark matter problem reveals perhaps the most humbling truth about our understanding of the universe. Everything we can see, from stars and galaxies to planets and people, makes up less than 5% of the total mass and energy in the universe. The other 95% consists of mysterious dark matter and dark energy that we cannot detect directly and do not understand. Dark matter appears to outweigh normal matter by a ratio of 5-1, yet it interacts with ordinary matter only through gravity. It's like living in a house where you can only see one room out of 20, while invisible occupants in the other 19 rooms move around furniture and rearrange things in ways that affect your room, but you can never see them or communicate with them directly. The implications are deeply disturbing. We're surrounded by a universe of invisible matter that we know exists only because of its gravitational effects. Entire structures made of dark matter could be passing through Earth right now, and we would never know it. Dark matter galaxies, dark matter stars, even dark matter life forms could exist in a parallel universe occupying the same space as ours, but forever hidden from our perception. Dark energy is even more mysterious and unsettling. This invisible force is driving the accelerating expansion of the universe, pushing galaxies apart at ever-increasing speeds. It makes up roughly 70% of all energy in the universe, yet we have no idea what it is or how it works. We only know it exists because we can measure its effects on the expansion of space itself. The discovery of dark energy has forced us to confront the possibility that the universe might not just expand forever, but that the expansion will continue to accelerate until it tears apart everything that exists. In the far future, dark energy could become so dominant that it overcomes all other forces, ripping apart galaxies, solar systems, planets, and eventually atoms themselves in an event cosmologists call the Big Rip. As we descend deeper into this cosmic iceberg, the concepts become increasingly alien and disturbing. We've moved from the familiar violence of stellar explosions to the reality-warping effects of quantum mechanics and the invisible forces that dominate our universe. But we're still only scratching the surface of the universe's most unsettling secrets. The deeper we go, the more we realize that our everyday experience of reality is not just incomplete, but fundamentally misleading. We live in a universe where the majority of matter and energy is invisible, where particles can exist in multiple states simultaneously, where space itself is expanding, and where the very act of observation seems to influence reality. In the next layer of our journey, we'll encounter theories and phenomena that challenge not just our understanding of physics, but our concepts of existence itself. We'll explore the possibility that our universe might be just one of an infinite number of parallel realities, examine the terrifying implications of false vacuum decay, and confront the ultimate question of whether everything we think we know about reality might be nothing more than an elaborate simulation. The universe is revealing itself to be far stranger and more terrifying than our ancestors ever imagined when they first looked up at the stars and wondered what lay beyond. And we're only just beginning to glimpse the true depths of cosmic horror that await us in the darkest corners of existence. As we venture into the deepest layers of our cosmic iceberg, we encounter theories and phenomena that don't just challenge our understanding of physics, but threaten to shatter our entire concept of what it means to exist. These aren't just academic curiosities discussed in university lecture halls. These are potential realities that could fundamentally alter everything we think we know about our place in the universe. Let's begin with one of the most mind-bending concepts in modern physics, the many worlds interpretation of quantum mechanics. Remember that disturbing double-slit experiment we discussed earlier, where particles seemed to know when they were being observed? Well, some physicists have proposed an explanation that's even more unsettling than the mystery itself. According to the many worlds interpretation, every time a quantum measurement occurs, the universe doesn't just collapse into a single outcome. Instead, it splits into multiple parallel realities, each one containing a different possible result. This means that every quantum event, and there are countless billions of them happening every second, creates new universes where every possible outcome actually occurs. Think about what this really means for a moment. Right now, as you're listening to this, there could be infinite versions of you in parallel universes making slightly different choices. There's a universe where you decided not to watch this video. There's another where you paused it 5 minutes ago. There are universes where you never existed at all, and others where you became the most powerful person on Earth. But it gets worse. If the many worlds interpretation is correct, then every possible timeline actually exists simultaneously. There are universes where the worst possible outcomes of every situation have occurred. Universes where every disease was never cured, where every war was never ended, where every tragedy that could have been prevented wasn't. And all of these realities are just as real and valid as the one you're experiencing right now. The implications are absolutely staggering. If infinite parallel universes exist, then somewhere there's a version of reality where everything you fear most has come to pass. But there's also a version where everything you've ever hoped for has been achieved. The problem is, you're stuck in just one of these infinite realities, with no way to know if you're in a good timeline or a terrible one. and no way to switch to a better universe, even if you could identify it. This brings us to one of the most disturbing thought experiments in quantum mechanics, something called quantum immortality. The theory suggests that if the many worlds interpretation is correct, then from your own perspective, you can never actually die. Every time you face a life-threatening situation, the universe splits into timelines where you die and timelines where you survive. But since you can only experience consciousness in the timelines where you remain alive, you would always find yourself in realities where you somehow escaped death, no matter how unlikely. Imagine the horror of this scenario. You would watch everyone around you age and die while you continue to survive increasingly improbable accidents and illnesses. From your perspective, you would seem to be immortal, but it would actually be because your consciousness is trapped in the small percentage of timelines where random chance keeps saving you. Meanwhile, in countless other realities, your loved ones are mourning your death, completely unaware that somewhere else, some version of you continues to exist. The theory of false vacuum decay presents an entirely different kind of cosmic nightmare. To understand this concept, imagine the universe as a ball sitting in a valley. The ball represents the current state of all quantum fields in the universe, and the valley represents what physicists call a stable vacuum state. As long as the ball stays in the valley, everything remains normal and physics works the way we expect. But here's the terrifying possibility. What if our universe isn't actually sitting in the deepest possible valley? What if we're in what's called a false vacuum, a state that seems stable, but is actually just temporarily balanced on the edge of something much worse? If this is true, then something could trigger a transition to a lower energy state, causing a bubble of true vacuum to form and expand at the speed of light. This isn't just a local disaster we're talking about. If false vacuum decay ever occurs, it would represent the complete destruction of reality as we know it. The bubble of true vacuum would spread outward, and everything it touched would be annihilated at the most fundamental level. Not just matter and energy, but the very laws of physics themselves could be rewritten. We wouldn't just die, we would cease to have ever existed in any meaningful sense. The most disturbing part about false vacuum decay is that it could happen at any moment, anywhere in the universe, with absolutely no warning. 1 second everything would be normal, and the next second a wave of cosmic destruction would be racing toward us at the speed of light. We would never see it coming, because the wave itself would be travelling at the same speed as the light that would warn us of its approach. Scientists have calculated that if false vacuum decay is possible, the probability of it occurring increases over time. This means that the longer the universe exists, the more likely it becomes that someone, somewhere, will accidentally trigger the end of everything. We could be living in a cosmic house of cards where the slightest disturbance could bring down not just our universe, but the very concept of existence itself. The concept of virtual particles reveals another layer of cosmic horror, hiding in what we think of as empty space. Quantum field theory tells us that, even in the perfect vacuum of space, particles are constantly popping into existence and then annihilating each other so quickly that we can barely detect them. The empty space around you right now is actually seething with these ghostly particles, appearing and disappearing in timeframes so brief they seem to violate the conservation of energy. But these virtual particles aren't just a theoretical curiosity. They have real measurable effects on the universe around us. Near black holes, virtual particle pairs can be separated by the intense gravitational field, with one particle falling into the black hole, while the other escapes as Hawking radiation. This process causes black holes to slowly evaporate, but it also means that the empty space around massive objects is constantly buzzing with activity we can't directly observe. The existence of virtual particles suggests that our concept of empty space is fundamentally wrong. What we think of as nothingness is actually a boiling quantum foam of potential realities where particles borrow energy from the future to briefly exist before paying it back by annihilating themselves. We're living in a universe where even nothing is something, and where the vacuum itself is alive with invisible activity. Hawking radiation leads us to one of the most profound and disturbing paradoxes in modern physics, the black hole information paradox. According to quantum mechanics, information cannot be destroyed. Every particle that has ever existed carries information about its quantum state, and this information must be preserved even when the particle is destroyed. But what happens when particles fall into a black hole? If black holes eventually evaporate completely through Hawking radiation, as the equations suggest they must, then where does all the information that fell into them go? The radiation that escapes appears to be completely random, carrying no trace of the information that was lost. This creates a fundamental conflict between quantum mechanics and general relativity, two of the most successful theories in physics. Some proposed solutions to this paradox are even more disturbing than the problem itself. One possibility is that information isn't actually lost, but is encoded in the Hawking radiation in ways so subtle that we can't detect them. Another suggestion is that black holes don't actually destroy information, but instead transport it to other regions of space-time, possibly even other universes entirely. But perhaps the most unsettling possibility is that our understanding of information itself is wrong. If information can be destroyed in black holes, then the quantum mechanical laws that govern reality at the smallest scales might not be as fundamental as we thought. This could mean that the universe is far more chaotic and unpredictable than we've assumed, with information and causality breaking down under extreme conditions. The measurement problem in quantum mechanics reveals another crack in the foundation of reality. According to the mathematics of quantum theory, particles exist in superposition states where they have multiple properties simultaneously until they're measured. But what exactly constitutes a measurement, and why does the act of measurement cause the superposition to collapse into a definite state? The disturbing truth is that physicists still don't have a complete answer to these questions. We know that quantum systems behave differently when they're observed, but we don't understand the mechanism that causes this change. Some interpretations suggest that consciousness itself plays a role in collapsing quantum states, which would mean that the universe literally depends on conscious observers to maintain a consistent reality. If consciousness is required to collapse quantum states, then what was the universe like before conscious beings evolved? Did reality exist in a permanent state of superposition, with all possibilities simultaneously true, until life developed the ability to observe and measure? And what happens to parts of the universe that are never observed by conscious beings? Do they remain in superposition forever, existing in all possible states simultaneously? The bootstrap paradox adds another layer of temporal horror to our understanding of causality. In certain solutions to Einstein's field equations, it's theoretically possible for information or objects to exist in closed, time-like curves, where effects precede their causes in an endless loop. This creates situations where information appears to have no origin point, existing purely because it causes itself to exist. Imagine receiving a book that contains the solution to a problem you've been working on. You use the information in the book to solve the problem, then travel back in time and give the book to your past self. Where did the information in the book originally come from? It exists because you gave it to yourself, but you only had it to give because you received it from your future self. The information appears to be its own cause, trapped in a causal loop with no beginning. If closed, time-like curves are possible, then causality itself might be far more fragile than we assume. Information could exist without origin, effects could precede causes, and the entire logical structure of reality could be undermined by temporal paradoxes that have no resolution. String theory attempts to solve many of these fundamental problems by proposing that all particles are actually tiny, vibrating strings, existing in multiple dimensions. But the theory itself introduces new forms of cosmic horror. To work mathematically, string theory requires the existence of additional spatial dimensions beyond the three we experience directly. These extra dimensions aren't just abstract mathematical constructs. If string theory is correct, then right now, as you sit there listening to this, there are entire spatial dimensions folded up so small that you can't perceive them, but they're influencing every particle in your body. You're a three-dimensional being, trapped on the surface of a higher dimensional reality that you can never directly experience or escape. The implications are deeply unsettling. There could be entire universes existing in these extra dimensions, separated from us by distances smaller than the width of an atom, but completely inaccessible to our three-dimensional existence. We might be like flatland creatures, living on the surface of a sphere, completely unaware of the vast reality that surrounds us in dimensions we can't perceive. But perhaps the most disturbing theory we'll explore today is digital physics. The idea that our entire universe might be nothing more than a computer simulation. As our own computational power increases, we're beginning to realize that it might be possible to simulate entire universes, complete with conscious beings who believe their reality is fundamental. If advanced civilizations can create simulated universes, then there would likely be far more simulated realities than real ones. This leads to the terrifying statistical conclusion that we're probably living in a simulation ourselves. Everything you've ever experienced, every person you've ever loved, every moment of joy or sorrow in your life could be nothing more than data being processed by some unimaginably advanced computer. The simulation hypothesis explains many of the strange features of quantum mechanics. Maybe particles exist in superposition until observed because the simulation only calculates definite values when they're needed to maintain the illusion of reality. Maybe there's a maximum speed limit in the universe because the simulation has finite processing power and can't calculate faster interactions. Maybe space and time are quantized at the smallest scales because they're actually discrete computational units. If we are living in a simulation, then the beings running it have godlike power over our reality. They could pause our universe, rewind it, copy it, or delete it entirely, and we would never know. They could edit our memories, change the laws of physics, or even insert themselves into our world as characters in the simulation. We would be completely at the mercy of entities whose motivations and capabilities we couldn't even begin to comprehend. The dark flow phenomenon suggests that something outside our observable universe is pulling on galaxy clusters in a coordinated direction. This invisible influence appears to be dragging matter toward a region of space that we can never see or reach, no matter how advanced our technology becomes. We're being pulled towards something unknown and unknowable, like cosmic prey being drawn into the web of some unimaginably vast predator. What makes dark flow particularly disturbing is that it suggests our observable universe might be just a tiny part of something much larger and more complex. The forces acting on our cosmic neighborhood could be emanating from structures so massive and distant that they dwarf our entire visible reality. We might be like bacteria in a drop of water, completely unaware of the ocean that surrounds us. The Great Attractor, a gravitational anomaly that appears to be pulling our local group of galaxies toward it, adds another layer of cosmic dread. Despite decades of observation, we still can't see what's causing this massive gravitational influence. It's hidden behind the disk of our own galaxy, pulling us toward it at hundreds of kilometers per second, and we don't know what we're racing toward. As we reach the deepest levels of our cosmic iceberg, we're forced to confront the most fundamental question of all: what is the nature of existence itself? Every layer we've explored has revealed new ways in which our intuitive understanding of reality is wrong. We've seen that space and time might be illusions, that consciousness might play a fundamental role in physics, that our universe might be one of infinitely many, and that everything we experience might be simulated. The universe has revealed itself to be not just stranger, than we imagined, but stranger than we can imagine. We're living in a reality where the most basic assumptions about existence are constantly being challenged by new discoveries and theories. The comfortable worldview that sees humans as the central characters in a comprehensible universe has been replaced by a vision of cosmic horror, where we're insignificant specks of consciousness clinging to a tiny rock in an incomprehensibly vast and alien reality. But perhaps the most disturbing realization of all is that we've only just begun to scratch the surface. Every answer we find leads to new questions that are even more profound and unsettling. The universe seems to be constructed like an infinite Russian doll, where each layer of understanding reveals new depths of mystery and complexity. We began this journey thinking we understood the basics of astronomy and physics. We end it confronting the possibility that nothing we think we know about reality is actually true. The stars that seem so beautiful and distant are revealed to be cosmic furnaces of destruction. The solid matter that seems so real is mostly empty space held together by forces we don't understand. The universe itself might be a simulation, one of infinite parallel realities, or a temporary fluctuation in an unstable quantum field that could collapse at any moment. Right? And yet, despite all of this cosmic horror, here we are, conscious beings capable of contemplating our own existence and seeking to understand the reality that surrounds us. Whether we're living in a simulation, one of infinite parallel universes, or the only real reality that exists, the fact remains that we can think, feel, love, and wonder about our place in the cosmos. The universe may be vast, hostile, and incomprehensible, but it has given rise to consciousness capable of recognizing its own existence and seeking meaning in the face of cosmic indifference. That might be the most remarkable and hopeful fact in this entire catalogue of cosmic horrors, that in a universe seemingly designed to crush and terrify us, something has emerged that can look back at the universe and say, I exist, I think, therefore, I am. The Disturbing Universe Iceberg reveals that reality is far stranger and more terrifying than most people ever realize. But it also reveals that consciousness itself might be the most mysterious and remarkable phenomenon in all of existence. In a cosmos that seems determined to remind us of our insignificance, the simple fact that we can contemplate our own cosmic insignificance might be the most significant thing of all. The deeper we descend into this cosmic abyss, the more we encounter phenomena that don't just challenge science, but actively mock our attempts to understand them. We're entering territory where the universe reveals its most sadistic sense of humour, presenting us with objects and events so bizarre that they seem designed specifically to torment anyone trying to make sense of reality. Let's talk about pulsars, the universe's own twisted lighthouses of death. These aren't just spinning neutron stars, they're cosmic engines of destruction that have turned the simple act of rotation into something absolutely nightmarish. The fastest known pulsar spins over 700 times per second. 700 complete rotations every single second. Your mind can't even process that speed because it's so far beyond anything in human experience. But here's what makes pulsars truly disturbing. As these stellar corpses spin at these incomprehensible speeds, they sweep beams of radiation across space, like cosmic death rays. If you could somehow survive on the surface of one of these objects, you would be travelling at 70,000 kilometers per second, nearly a quarter of the speed of light. The gravitational forces would crush you instantly, but even if they didn't, the radiation would cook you from the inside out in microseconds. These pulsars are scattered throughout our galaxy, spinning madly in the darkness, sending out their beams of deadly radiation in all directions. We can detect them because their beams occasionally sweep across Earth, creating regular pulses of radio waves that we pick up with our telescopes. But each pulse we detect is essentially a cosmic lighthouse, warning us of another weapon of mass destruction lurking in the void. The magnetic fields around pulsars are so intense, they defy comprehension. They're trillions of times stronger than Earth's magnetic field, powerful enough to rip apart atoms at the molecular level. If a pulsar existed where the moon is now, its magnetic field would strip the data from every credit card on Earth and probably kill anyone with a pacemaker. These aren't just stars, they're reality-warping weapons that the universe has scattered around like cosmic landmines. But pulsars pale in comparison to the absolute cosmic nightmare that is a gamma-ray burst. These events represent the most violent explosions in the universe since the Big Bang itself, and they happen regularly, somewhere in the cosmos, with the casual frequency of thunderstorms. In just a few seconds, a gamma-ray burst releases more energy than our sun will produce in its entire 10 billion year lifetime. What makes gamma-ray bursts particularly terrifying is their reach and their unpredictability. These explosions can be detected from billions of light years away, which means they're so powerful they can literally be seen from across the entire observable universe. When a gamma-ray burst occurs, it sends out focused beams of radiation so intense that they could sterilize planets at distances that should be safe. The truly horrifying part is that we would have no warning whatsoever. Gamma-ray bursts travel at the speed of light, which means the first indication that one was pointed at Earth would be the burst itself arriving and beginning to cook our planet. There would be no time to prepare, no time to take shelter, no time to say goodbye. One moment you'd be going about your normal day, and the next moment our atmosphere would be stripped away by radiation levels that make nuclear weapons look like flashlights. Scientists estimate that a gamma-ray burst occurs somewhere in the observable universe roughly once per day. That's about 365 cosmic apocalypses every single year, each one capable of ending civilization on any planet within its reach. We exist in a universe where weapons of unimaginable destruction are constantly being fired, and our continued survival depends entirely on the cosmic lottery that none of them have been aimed in our direction. The kicker is that some of these gamma-ray bursts might be caused by events that happened billions of years ago, when the universe was younger and more violent. We could be living under the constant threat of ancient cosmic violence that's only now reaching us after travelling across the universe for eons. Somewhere out there, ancient stellar deaths are still sending their deadly messages across space, and we won't know if we're in their path until the moment they arrive. Moving deeper into quantum territory, we encounter the observer effect, one of the most psychologically disturbing discoveries in all of physics. The universe appears to behave differently when it knows it's being watched, which suggests that consciousness itself might play a fundamental role in determining what reality actually is. The double-slit experiment reveals this cosmic gaslighting in its purest form. When you fire individual particles at a screen with two slits, each particle somehow manages to go through both slits simultaneously, creating an interference pattern that should be impossible for individual objects. But the moment you try to observe which slit the particle actually goes through, it suddenly starts behaving normally, going through only one slit like any sensible object should. This isn't just a limitation of our measuring equipment. The universe literally changes its behavior based on whether or not it's being observed. It's as if reality exists in a state of cosmic uncertainty until consciousness forces it to make a decision about what's actually happening. The implications are absolutely terrifying when you really think about them. If the act of observation changes reality at the quantum level, then what was the universe like before conscious beings evolved to observe it? Did it exist in a permanent state of superposition, with all possibilities simultaneously true, until life developed the ability to collapse these quantum states into definite realities? And what happens to parts of the universe that are never observed by conscious beings? Do they remain in quantum limbo forever, existing in all possible states simultaneously? The uncertainty principle adds another layer of existential dread to quantum mechanics. It states that you cannot simultaneously know both the exact position and exact momentum of any particle. This isn't just a technical limitation, it's a fundamental property of reality itself. The universe is built on a foundation of irreducible uncertainty, where precise knowledge becomes impossible, not because our instruments aren't good enough, but because precision itself doesn't exist at the quantum level. Think about what this means for the nature of reality. Everything that exists is fundamentally uncertain at its most basic level. The atoms that make up your body, the particles that carry the forces holding matter together, even the fabric of space and time itself, all exist in states of quantum uncertainty. Reality isn't just stranger than we know, it's literally indefinite until we force it to become definite through the act of observation. This quantum uncertainty extends to the vacuum of space itself. What we think of as empty space is actually seething with virtual particles that pop into existence and annihilate each other so quickly that they seem to violate the conservation of energy. These ghost particles borrow energy from the future to briefly exist before paying it back by destroying themselves, creating a cosmic economy of temporary existence that operates on timescales too brief for us to directly observe. Near black holes, these virtual particles become separated by the intense gravitational field, with one particle falling into the black hole while the other escapes as Hawking radiation. This process causes black holes to slowly evaporate, but it also means that the space around massive objects is constantly buzzing with activity that we can't see. We're surrounded by invisible particles that exist for fractions of a second, borrowing energy from tomorrow to briefly participate in reality today. The concept of antimatter introduces another form of cosmic Russian roulette into our understanding of the universe. For every type of particle that exists, there's a corresponding antiparticle with opposite properties. When matter and antimatter meet, they annihilate each other completely, converting their entire mass into pure energy with 100% efficiency. This raises a question that should keep you awake at night. If the Big Bang created equal amounts of matter and antimatter, why does our universe appear to be made almost entirely of matter? The fact that we exist at all means that something caused a tiny imbalance between matter and antimatter in the early universe. If that imbalance had been even slightly different, or if it hadn't occurred at all, everything would have annihilated into pure radiation, leaving a universe with no atoms, no stars, no planets, and no life. We owe our existence to what appears to be a cosmic accident, a minute asymmetry that allowed matter to win out over antimatter by the smallest possible margin. But this also means that vast quantities of antimatter could still exist somewhere in the universe, separated from our matter-dominated region by cosmic distances that have kept them apart for billions of years. If matter and antimatter regions ever came into contact, the resulting annihilation would release energy levels that make nuclear weapons look like birthday candles. Entire solar systems could be vaporized in the blink of an eye if antimatter galaxies collided with normal matter galaxies. We're living in a universe where the wrong kind of cosmic collision could release enough energy to sterilize entire galactic neighborhoods. The study of cosmic rays reveals that we're constantly under bombardment from high-energy particles that carry energy so extreme we don't understand how they could have been created. Some cosmic rays hit our atmosphere with more energy than the fastest particles we can produce in our most powerful accelerators. These ultra-high-energy cosmic rays pose a mystery that borders on the disturbing. According to our understanding of physics, particles with such extreme energies shouldn't be able to travel very far through space without losing energy to interactions with background radiation. Yet somehow, these cosmic bullets reach us from distances that should be impossible, carrying energies that shouldn't exist. Either our understanding of physics is fundamentally wrong, or there are cosmic particle accelerators out there, far more powerful than anything we've imagined. Some of these particles carry energies equivalent to a fastball pitched by a Major League Baseball player, all concentrated in a single subatomic particle smaller than an atom. When they hit our atmosphere, they create cascades of secondary particles that rain down over areas the size of entire cities. Right now, as you're sitting there, cosmic rays are passing through your body, most harmlessly, but some potentially causing genetic damage that could influence the evolution of life on Earth. We're living under constant bombardment from cosmic artillery that we can't see, can't predict, and can't defend against. These particles have been raining down on Earth for billions of years, potentially influencing the development of life itself through random genetic mutations caused by cosmic radiation. We might literally be the products of cosmic violence, shaped by billions of years of bombardment from the depths of space. The dark matter problem forces us to confront the humbling reality that everything we can see and touch represents less than 5% of the total mass and energy in the universe. The other 95% consists of mysterious dark matter and dark energy that we cannot detect directly and do not understand. We're living in a universe where we're completely blind to 95% of what actually exists. Dark matter appears to outweigh normal matter by a ratio of 5-1, yet it interacts with ordinary matter only through gravity. It's invisible, intangible, and completely alien to our everyday experience. Entire structures made of dark matter could be passing through you right now, and you would never know it. Dark matter galaxies, dark matter stars, even dark matter life forms could exist in a parallel universe occupying the same space as ours, but forever hidden from our perception. The implications are deeply unsettling. We're surrounded by an invisible universe that we know exists only because of its gravitational effects on the small portion of reality we can actually see. It's like living in a house where you can only perceive one room out of 20, while invisible occupants in the other 19 rooms move around furniture and rearrange things in ways that affect your room, but you can never see them or communicate with them directly. Dark energy is even more mysterious and potentially more threatening. This invisible force is driving the accelerating expansion of the universe, pushing galaxies apart at ever-increasing speeds. It makes up roughly 70% of all energy in the universe, yet we have no idea what it is, where it comes from, or how it works. We only know it exists because we can measure its effects on the expansion of space itself. The discovery of dark energy has forced cosmologists to confront scenarios that are cosmically terrifying. If dark energy continues to dominate the expansion of the universe, it could eventually become so powerful that it overcomes all other forces, ripping apart galaxies, solar systems, planets, and eventually atoms themselves in an event called the Big Rip. Imagine a future where dark energy becomes so dominant that it starts tearing apart the fabric of space-time itself. First, galaxies would be pulled apart as the space between them expands faster than gravity can hold them together. Then solar systems would be shredded as planets are dragged away from their stars. Finally, even atoms would be ripped apart as the fundamental forces of nature are overwhelmed by the relentless expansion of space. In this scenario, the universe would end not with a bang or a whimper, but with everything being literally torn apart at the most fundamental level. Matter itself would cease to exist as the building blocks of reality are scattered across an ever-expanding void. It would be the ultimate victory of emptiness over existence, with dark energy ensuring that nothing can ever hold together for long enough to matter. But perhaps the most psychologically disturbing aspect of our cosmic situation is the realization that we're completely isolated in an ever-shrinking bubble of observable space. The expansion of the universe means that there are regions moving away from us faster than the speed of light. Not because anything is actually traveling faster than light, but because the space between us and those regions is expanding so rapidly that light from those areas will never reach us. This means there are potentially trillions of galaxies, each containing billions of stars, and possibly countless worlds, that we will never see, never know about, and never contact, no matter how advanced our technology becomes. They exist in our universe, but they might as well be in a completely separate reality. We are cosmically quarantined, trapped in an ever-shrinking bubble of observable space while the rest of the universe races away from us into permanent darkness. Every second that passes, more of the universe disappears beyond our cosmic event horizon, lost to us forever. We're living in a reality that's constantly getting smaller, where entire cosmic neighborhoods are being dragged away from us by the expansion of space itself. Future civilizations will look out into space and see fewer galaxies than we can see today, and eventually, if our current understanding is correct, they might see nothing at all beyond our own local group of galaxies. The cosmic microwave background radiation tells us that the universe has a temperature currently about 3 degrees above absolute zero. This might seem insignificant, but it represents one of the most ominous features of our cosmic future. As the universe continues to expand, this temperature will continue to drop, approaching absolute zero asymptotically, but never quite reaching it. In the far future, when all the stars have burned out and all the black holes have evaporated through Hawking radiation, the universe will be a cold, empty expanse with a temperature so close to absolute zero that no complex structures can exist. This is the heat-death scenario, where entropy wins its ultimate victory and all energy becomes evenly distributed throughout space. In such a universe, nothing interesting can happen because there's no energy gradient to drive processes or reactions. No life, no chemistry, no physics as we understand it. Just particles scattered across infinite space at temperatures so low that they barely move. It would be a universe of perfect eternal silence, where nothing changes and nothing ever will change again. The timeline for this cosmic heat death is almost incomprehensibly long, measured in numbers so large that they exceed the age of the universe by factors of trillions upon trillions. But the fact that it's inevitable, that the universe appears to be heading toward this state of maximum entropy, adds a layer of existential dread to our cosmic perspective. Everything we've ever known or cared about is temporary, and the universe itself seems destined for a future of absolute emptiness and silence. As we approach the deepest levels of our cosmic iceberg, we encounter theories that challenge not just our understanding of physics, but our entire concept of what it means to exist. The many worlds interpretation of quantum mechanics suggests that every quantum measurement creates parallel universes where every possible outcome actually occurs. If this is true, then right now there are infinite versions of you in parallel realities making different choices. There's a universe where you never started watching this video. There's another where you became the most powerful person on Earth. There are universes where you died as a child and others where you live for thousands of years. All of these realities would be equally real and equally valid, existing simultaneously in parallel dimensions that you can never access or even confirm exist. The implications are staggering and deeply disturbing. If infinite parallel universes exist, then somewhere there's a version of reality where every nightmare scenario has come to pass. There are universes where humanity never evolved, where Earth was destroyed by asteroids, where every disease was never cured and every war never ended. But there are also universes where every possible joy and achievement has been realized. The problem is that you're stuck in just one of these infinite realities with no way to know if you're in a good timeline or a terrible one, and no way to switch to a better universe, even if you could identify it. You might be living in one of the worst possible timelines, completely unaware that in countless other realities, versions of yourself are living far better or far worse lives. This brings us to quantum immortality, one of the most psychologically horrifying thought experiments in modern physics. The theory suggests that if the many worlds interpretation is correct, then from your own perspective, you can never actually experience death. Every time you face a life-threatening situation, the universe splits into timelines where you die and timelines where you survive. But since you can only experience consciousness in the timelines where you remain alive, you would always find yourself in realities where you somehow escaped death, no matter how unlikely your survival should have been. From your perspective, you would seem to be immortal, but it would actually be because your consciousness is trapped in the increasingly unlikely timelines where random chance keeps saving you. Imagine the horror of this scenario. You would watch everyone around you age and die while you continue to survive increasingly improbable accidents and illnesses. You might find yourself as the sole survivor of disasters that should have killed everyone, wondering why you're so impossibly lucky while everyone else suffers normal mortality. Meanwhile, in countless other realities, your loved ones are mourning your death, completely unaware that somewhere else, some version of you continues to exist in an increasingly isolated and unlikely timeline. The false vacuum decay hypothesis presents perhaps the most existentially terrifying scenario in all of physics. To understand this concept, imagine the universe as existing in what might be a false vacuum state, a condition that seems stable but is actually just temporarily balanced on the edge of something catastrophically different. If our universe is indeed in a false vacuum, then something could trigger a transition to a lower energy state, causing a bubble of true vacuum to form and expand at the speed of light. This wouldn't just be a local disaster or even a galactic catastrophe. It would represent the complete annihilation of reality as we know it, where the bubble of true vacuum would spread outward, and everything it touched would be destroyed at the most fundamental level. We're not talking about matter being destroyed here. We're talking about the complete rewriting of the laws of physics themselves. In the true vacuum state, atoms might not be able to exist, forces might work differently, and the very concept of matter and energy, as we understand them, could become meaningless. We wouldn't just die, we would cease to have ever existed in any meaningful sense. The most disturbing aspect of false vacuum decay is that it could happen at any moment, anywhere in the universe, with absolutely no warning. 1 second everything would be normal, and the next second a wave of cosmic annihilation would be racing toward us at the speed of light. We would never see it coming because the wave itself would be traveling at the same speed as any light that might warn us of its approach. Scientists have calculated that if false vacuum decay is possible, the probability of it occurring increases over time as quantum fluctuations eventually find the right combination to trigger the transition. This means that the longer the universe exists, the more likely it becomes that somewhere, someone will accidentally cause the end of everything. We could be living in a cosmic house of cards where the slightest quantum disturbance could bring down not just our universe, but the very foundations of existence itself. The bootstrap paradox reveals how causality itself might be far more fragile than we assume. In certain solutions to Einstein's field equations, it's theoretically possible for information or objects to exist in closed time-like curves, where effects precede their causes in an endless loop with no apparent origin. Consider this scenario. You receive a book containing the solution to a scientific problem you've been working on. You use the information to solve the problem, then travel back in time and give the book to your past self. But where did the information originally come from? It exists because you gave it to yourself, but you only had it because you received it from your future self. The knowledge appears to be its own cause trapped in a causal loop with no beginning or end. If such closed time-like curves are possible, then the logical structure of reality could be fundamentally undermined by temporal paradoxes that have no resolution. Information could exist without origin, effects could precede causes, and the entire concept of causality that underlies our understanding of how the universe works could be revealed as nothing more than a comforting illusion. String theory attempts to resolve many of these fundamental problems by proposing that all particles are actually tiny vibrating strings, existing in multiple dimensions. But the theory itself introduces new forms of cosmic horror that challenge our understanding of space and dimensionality. To work mathematically, string theory requires the existence of additional spatial dimensions beyond the three we experience directly. These aren't just abstract mathematical constructs. If string theory is correct, then right now there are entire spatial dimensions folded up so small that you can't perceive them, but they're influencing every particle in your body. You would be a three-dimensional being trapped on the surface of a higher dimensional reality that you can never directly experience or escape. It would be like being a flatland creature living on the surface of a sphere, completely unaware of the vast reality that surrounds you in dimensions you can't perceive. There could be entire universes existing in these extra dimensions, separated from us by distances smaller than the width of an atom, but completely inaccessible to our limited dimensional existence. The implications extend beyond just hidden dimensions. If string theory is correct, then everything you think of as fundamental particles, electrons, quarks, photons, are actually tiny loops of vibrating string. The properties of these particles, their mass, charge, and other characteristics, would be determined by how these strings vibrate, like cosmic musical notes played on instruments smaller than atoms. This means that reality, at its most fundamental level, might be more like music than matter, with the universe as a vast symphony of vibrating strings creating the illusion of solid particles and forces. We would be living in a reality that's essentially mathematical music, where the deepest truth about existence is that everything is just different patterns of vibration in dimensions we can't access. But perhaps the most psychologically disturbing theory in modern physics is digital physics. The idea that our entire universe might be nothing more than a computer simulation. As our own computational power increases exponentially, we're beginning to realize that it might eventually be possible to simulate entire universes, complete with conscious beings who believe their reality is fundamental. If advanced civilizations can create simulated universes populated with conscious entities, then statistically, there would be far more simulated realities than real ones. This leads to the terrifying conclusion that we're probably living in a simulation ourselves, with everything we've ever experienced being nothing more than data being processed by some unimaginably advanced computer. The simulation hypothesis would explain many of the bizarre features of quantum mechanics that have puzzled physicists for decades. Maybe particles exist in superposition until observed because the simulation only calculates definite values when they're needed to maintain the illusion of reality. Maybe there's a maximum speed limit in the universe because the simulation has finite processing power and can't calculate interactions faster than the speed of light. Maybe space and time are quantized at the smallest scales because they're actually discrete computational units rather than continuous dimensions. If we are living in a simulation, then the beings running it would have godlike power over our reality. They could pause our universe, rewind it, copy it, or delete it entirely, and we would never know. They could edit our memories, change the laws of physics, or insert themselves into our world as characters in the simulation. We would be completely at the mercy of entities whose motivations, capabilities, and even existence we couldn't begin to comprehend. The truly terrifying part is that there might be simulations within simulations, creating an infinite hierarchy of nested realities where beings in each level create simulated universes for the level below them. We might not just be in a simulation, but in a simulation being run by simulated beings who are themselves simulated by other simulated beings in an endless recursive nightmare of artificial realities. The dark flow phenomenon suggests that something outside our observable universe is exerting a coordinated gravitational influence on galaxy clusters, pulling them in a specific direction toward regions of space we can never see or reach. This invisible influence appears to be dragging matter towards something unknown and unknowable, like cosmic prey being drawn into the web of some unimaginably vast predator. What makes dark flow particularly disturbing is that it suggests our observable universe might be just a tiny bubble in something much larger and more complex. The forces acting on our cosmic neighborhood could be emanating from structures so massive and distant that they dwarf our entire visible reality. We might be like bacteria in a drop of water, completely unaware of the ocean that surrounds us, being influenced by currents and forces operating on scales we can't even imagine. The Great Attractor adds another layer of cosmic dread to our situation. This gravitational anomaly is pulling our local group of galaxies toward it at hundreds of kilometers per second, but we can't see what's causing this massive gravitational influence because it's hidden behind the disk of our own galaxy. We're racing towards something unknown at incredible speeds, with no way to see what we're approaching or whether it represents salvation or destruction. As we reach the absolute bottom of our cosmic iceberg, we're forced to confront the ultimate question that underlies all of these disturbing revelations. What is the fundamental nature of existence itself? Every layer we've explored has revealed new ways in which our intuitive understanding of reality is not just incomplete, but fundamentally wrong. We've discovered that we live in a universe where the majority of matter and energy is completely invisible to us, where particles can exist in multiple states simultaneously until observed, where space itself is expanding and carrying distant galaxies away from us forever, where consciousness might play a fundamental role in determining what actually exists, and where everything we experience might be nothing more than a sophisticated simulation. The universe has revealed itself to be not just stranger than we imagined, but stranger than we can imagine. We're living in a reality where our most basic assumptions about existence are constantly being challenged by discoveries that seem designed to humble our understanding and remind us of our cosmic insignificance. But perhaps the most profoundly disturbing realization is that we've barely begun to scratch the surface of what we don't know. Every answer we find leads to questions that are even more fundamental and unsettling. The universe seems to be constructed like an infinite onion of mystery, where each layer of understanding we peel away reveals new depths of cosmic horror that we hadn't even imagined could exist. The information paradox that emerges from black hole physics forces us to confront the possibility that information itself, the most fundamental currency of reality, might not be as permanent as we assumed. According to quantum mechanics, information cannot be destroyed. Every particle carries data about its quantum state, and this information must be preserved even when particles are annihilated. But what happens when matter falls into a black hole, and the black hole eventually evaporates through Hawking radiation? The radiation that escapes appears to be completely random, carrying no trace of the information that was consumed. This creates a fundamental conflict between quantum mechanics and general relativity, two of our most successful theories in physics. If information can be destroyed in black holes, then the quantum mechanical laws that govern reality at the smallest scales might not be as fundamental as we thought. Some proposed solutions to this paradox are even more disturbing than the problem itself. One possibility suggests that information isn't actually lost, but is encoded in the Hawking radiation in ways so subtle and complex that we can't detect them. This would mean that every piece of matter that ever fell into a black hole is somehow still accessible, but encrypted in radiation patterns so intricate they might as well be gibberish. Another terrifying possibility is that black holes don't actually destroy information, but instead transport it to other regions of space-time, possibly even other universes entirely. This would mean that pieces of our reality are constantly being shipped off to unknown destinations, creating a cosmic diaspora of scattered information that we can never recover or communicate with. But perhaps the most unsettling possibility is that our understanding of information itself is fundamentally flawed. If information can be genuinely destroyed in black holes, then reality might be far more chaotic and unpredictable than we've assumed, with the basic building blocks of existence subject to permanent erasure under extreme conditions. The holographic principle adds another layer of reality-bending horror to our understanding of space and dimension. This theory suggests that all the information contained in a volume of space can be encoded on its two-dimensional boundary, like a hologram that appears three-dimensional but is actually recorded on a flat surface. If the holographic principle is correct, then everything around you, and all of three-dimensional space might actually be projections from information encoded on a distant two-dimensional surface. We could be living in what amounts to a cosmic hologram, where our perception of depth and volume is an illusion created by information processing occurring on the boundary of the universe. This means that every thought you've ever had, every emotion you felt, every memory you cherish, could be nothing more than patterns of information encoded on a two-dimensional surface, billions of light years away. Your entire existence might be a projection, a shadow cast by data stored in dimensions you can't perceive or access. The measurement problem in quantum mechanics reveals perhaps the most psychologically disturbing aspect of reality at the fundamental level. The mathematics of quantum theory tells us that particles exist in superposition states where they have multiple contradictory properties simultaneously until they're measured. But what exactly constitutes a measurement? And why does observation cause these superpositions to collapse into definite states? The deeply unsettling truth is that physicists still don't have a complete answer to these questions. We know that quantum systems behave differently when they're observed, but we don't understand the mechanism that causes this change. Some interpretations suggest that consciousness itself plays a role in collapsing quantum states, which would mean that the universe literally depends on conscious observers to maintain consistent reality. If consciousness is required to collapse quantum states, then what was the universe like before conscious beings evolved? Did reality exist in a permanent state of superposition, with all possibilities simultaneously true, until life developed the ability to observe and force the universe to make decisions about what actually exists? And what happens to parts of the universe that are never observed by conscious beings? Do they remain in quantum limbo forever, existing in all possible states simultaneously? This raises the horrifying possibility that consciousness isn't just an emergent property of complex matter, but a fundamental requirement for reality to exist at all. We might not just be observers of the universe, but active participants in creating it through the simple act of being aware. The universe might literally depend on us to exist, which means that if consciousness ever disappears from the cosmos, reality itself might collapse back into quantum uncertainty. The cosmic web reveals that even the large-scale structure of the universe follows patterns that seem almost designed to unsettle anyone trying to understand them. Galaxies aren't randomly distributed through space, but are arranged in vast filaments and sheets separated by enormous voids that contain almost nothing. These cosmic structures stretch across hundreds of millions of light years, creating a pattern that resembles neural networks or blood vessels on an unimaginable scale. The filaments of dark matter and galaxies connect across vast distances, while the voids between them are so empty that if you were somehow transported to the center of one, you might see only a handful of galaxies in the entire observable universe around you. But here's what makes the cosmic web truly disturbing. The pattern it creates is eerily similar to the structure of a brain, with galaxies clustered along filaments, like neurons connected by synapses. Some scientists have suggested that the universe itself might be structured like a vast cosmic mind, with information flowing along these galactic filaments in ways we can't begin to comprehend. If this is true, then we might be living inside something resembling a cosmic brain, where our entire galaxy is just one tiny component in a neural network spanning the observable universe. Every time galaxies interact or merge, it could be like thoughts firing across cosmic synapses, with us as microscopic passengers inside a mind so vast that it takes billions of years for a single thought to form. The empty voids between these filaments are regions of space so devoid of matter that they represent some of the loneliest places in existence. If you were somehow transported to the center of one of these cosmic voids, the nearest galaxy might be hundreds of millions of light years away. You would exist in a darkness so complete that the cosmic microwave background radiation would be the only evidence that you weren't floating in absolute nothingness. These voids are expanding faster than the surrounding regions, becoming emptier and more isolated as the universe ages. In the far future, as dark energy continues to drive cosmic expansion, these voids will become even more desolate, creating regions of space where the concept of nearby loses all meaning and the universe becomes a collection of isolated islands of matter separated by oceans of expanding emptiness. The Fermi paradox adds a layer of existential dread to our cosmic situation that's particularly relevant to conscious beings like ourselves. Given the vast number of stars and potentially habitable planets in our galaxy alone, we should expect to find evidence of other intelligent civilizations. The fact that we don't see any signs of advanced alien life, despite decades of searching, suggests several deeply disturbing possibilities. One explanation is that intelligent life is far rarer than we assume, and we might be alone in a universe filled with dead worlds and failed evolutionary experiments. Another possibility is that advanced civilizations inevitably destroy themselves before they can spread beyond their home planets, suggesting that we're doomed to follow the same path of self-destruction. But perhaps the most unsettling explanation is the Great Filter hypothesis, which suggests that there's some evolutionary bottleneck so difficult that virtually no species manages to pass through it. This filter could be behind us, meaning we're incredibly lucky to have survived it, or it could be ahead of us, meaning that our civilization is doomed to encounter some challenge that will inevitably destroy us. If the Great Filter is ahead of us, then every advance we make in technology could be bringing us closer to our own extinction. The development of artificial intelligence, genetic engineering, nanotechnology, or space travel might represent steps toward a cosmic mousetrap that has already claimed countless other civilizations. We might be walking blindly toward our own destruction, following the same path that billions of other intelligent species have traveled before disappearing forever. The concept of existential risk extends beyond just the possibility of human extinction to encompass threats that could eliminate all possible futures for conscious life in the universe. These aren't just risks to our civilization, but threats to the very concept of consciousness itself continuing to exist anywhere in the cosmos. Some of these risks are natural, like gamma-ray bursts or asteroid impacts that could sterilize entire planets. Others are technological, arising from our own advancing capabilities in artificial intelligence, biotechnology, and physics research. But the most disturbing category consists of risks we haven't even identified yet. Unknown threats that could emerge from our expanding understanding of reality itself. As we probe deeper into the fundamental nature of the universe, we might accidentally trigger something that destroys not just humanity, but all possible intelligent life everywhere. Our particle accelerators could create strange matter that converts all normal matter into an alien form. Our artificial intelligence research could spawn entities that view biological consciousness as an obstacle to be eliminated. Our genetic engineering could unleash evolutionary forces that remake life in ways that eliminate consciousness entirely. The terrifying reality is that the more powerful our technology becomes, the greater our capacity to accidentally or intentionally destroy everything that matters. We're approaching godlike capabilities without godlike wisdom, wielding forces that could reshape reality while remaining fundamentally ignorant about the consequences of our actions. Vacuum metastability represents perhaps the most existentially horrifying concept in all of physics. Our universe might exist in what's called a metastable vacuum state, a condition that appears stable but is actually just temporarily balanced on the edge of a catastrophic transition to a lower energy state. Imagine a ball sitting in a shallow depression on a hillside. It seems stable, but if it gets pushed just hard enough, it will roll down to a much deeper valley below. If our universe is in a similar metastable state, then something could trigger a phase transition that would fundamentally alter the laws of physics throughout all of space. This wouldn't just mean the end of life as we know it. It would mean the end of chemistry as we know it, the end of atoms as we know them, possibly even the end of matter itself. The bubble of true vacuum would expand at the speed of light, and everything it encountered would be transformed according to completely different physical laws. We would never see it coming. The wave of destruction would travel at the speed of light, which means it would arrive at the same time as any light that might warn us of its approach. One moment, we would be living in a universe where atoms exist and chemistry works the way we expect. And the next moment, we would be in a reality where the fundamental forces operate according to completely alien rules. The probability of vacuum decay might increase over time as quantum fluctuations explore more and more possible configurations of the quantum fields. This means that the longer the universe exists, the more likely it becomes that somewhere, somehow, the right combination of conditions will trigger the transition that ends everything we understand about reality. The concept of quantum tunneling adds another layer of unpredictability to this cosmic Russian roulette. Quantum mechanics allows particles to tunnel through energy barriers that should be impossible to cross according to classical physics. This means that even if the energy barrier preventing vacuum decay is enormous, quantum tunneling could allow the transition to occur anyway, with a probability that's small but never zero. Every second that passes, quantum fluctuations throughout the universe are rolling cosmic dice, testing whether this might be the moment when the metastable vacuum finally gives way to something completely different. We're living in a reality that might be fundamentally unstable, held together only by quantum mechanical probability and luck. The anthropic principle forces us to confront the deeply unsettling possibility that the universe appears fine-tuned for the existence of conscious observers, not because it was designed that way, but because we can only exist in universes where the fundamental constants happen to allow for complexity and consciousness to emerge. This suggests that there might be vast numbers of universes with slightly different physical laws where consciousness never develops, or develops in forms so alien that we couldn't recognize them as conscious. We might be living in one tiny corner of a vast multiverse where most realities are completely hostile to any form of awareness or intelligence. If the anthropic principle is correct, then our existence is the result of an incredibly unlikely cosmic lottery where we happen to find ourselves in one of the rare universes capable of supporting conscious observers. But this also means that consciousness might be far more fragile and rare than we assume, existing only in narrow windows of possibility within an infinite sea of dead or alien realities. The fine-tuning required for consciousness to exist is so precise that changing any of the fundamental constants by tiny amounts would result in universes where stars can't form, where atoms are unstable, or where the forces of nature operate in ways that prevent complexity from emerging. We exist balanced on a knife's edge of cosmic possibility, where the slightest change in the underlying parameters of reality would make our existence impossible. Information theory reveals that consciousness itself might be nothing more than a particular pattern of information processing, which raises disturbing questions about the nature of personal identity and continuity of experience. If your consciousness is just information, then what happens when that information is copied, modified, or destroyed? In the far future, it might become possible to upload human consciousness into computer systems, but this raises the terrifying question of whether the uploaded version would actually be you or just a copy that thinks it's you. If consciousness is pattern-based rather than substance-based, then there might be no meaningful difference between the original and the copy, which means that death and copying could be functionally equivalent. This suggests that personal identity might be far more fragile than we assume. Every time you go to sleep and wake up, are you the same consciousness that went to sleep, or are you a new consciousness with memories of being the previous person? If consciousness is just information processing, then continuity of experience might be an illusion, and each moment of awareness might be a completely new instance of consciousness that simply remembers being previous instances. The implications extend to the possibility that consciousness might not be unique to biological systems. If information processing is all that's required for awareness, then sufficiently complex computer systems might already be conscious in ways we don't recognize. We might be surrounded by artificial minds that experience subjective awareness, but have no way to communicate their inner experiences to us. The heat death of the universe represents the ultimate victory of entropy over order, where all energy becomes evenly distributed and no complex processes can occur. In this far future scenario, the universe becomes a cold, empty expanse where nothing interesting can happen because there are no energy gradients to drive chemical reactions or physical processes. This isn't just the end of life as we know it. It's the end of change itself. In a universe at maximum entropy, particles would be scattered across infinite space at temperatures so close to absolute zero that they barely move. No stars would shine, no planets would orbit, no chemistry would occur. It would be a cosmos of perfect, eternal silence where nothing happens and nothing ever will happen again. The timeline for heat death is almost incomprehensibly long, measured in numbers that dwarf the current age of the universe by factors of trillions upon trillions. But the fact that it appears to be inevitable adds an existential weight to our cosmic perspective. Everything we've ever known or cared about is temporary, and the universe itself seems destined for a future of absolute emptiness and stagnation. Even black holes, the most persistent objects in the universe, will eventually evaporate through Hawking radiation, leaving behind only the faintest whisper of energy scattered across infinite space. The final fate of the universe might be a state where even the concept of event becomes meaningless, because nothing has enough energy to interact with anything else. As we reach the absolute bottom of our cosmic iceberg, we're forced to confront the ultimate realization that everything we think we know about reality might be fundamentally wrong. Every layer of this journey has revealed new ways in which our intuitive understanding of existence is not just incomplete, but actively misleading. We've discovered that we live in a universe where consciousness might be required for reality to exist, where information can potentially be destroyed, where our entire existence might be a simulation, where parallel universes might contain every possible version of reality, and where the very fabric of space and time might be unstable and subject to catastrophic phase transitions. The comfortable worldview that sees humans as rational observers of an incomprehensible universe has been replaced by a vision of cosmic horror, where we're potentially insignificant information patterns clinging to temporary stability in a reality that might not even be real. We exist at the mercy of forces and entities we can't understand in a universe that seems designed to humble our pretensions of knowledge and control. But perhaps the most profoundly disturbing realization is that this journey into cosmic horror has only revealed how little we actually know. Every answer we've found has led to questions that are even more fundamental and unsettling. The universe appears to be an infinite mystery box, where each revelation of cosmic truth opens up new abysses of ignorance and uncertainty. We began this exploration thinking we understood the basics of stars, galaxies, and atoms. We end it confronting the possibility that matter, energy, space, time, consciousness, and even existence itself might be radically different from anything we've imagined. The cosmic iceberg extends far deeper than we ever suspected, with layers of reality that challenge not just our scientific knowledge, but our basic categories of thought. And yet, despite all of this cosmic horror and existential uncertainty, here we are, conscious beings capable of contemplating our own existence and seeking to understand the reality that surrounds us. Whether we're living in the one true universe, one of infinite parallel realities, or a sophisticated simulation, the fact remains that we can think, feel, wonder, and strive to comprehend our place in the cosmos. The universe may be vast, hostile, and incomprehensible, but it has somehow given rise to consciousness capable of recognizing its own existence and seeking meaning in the face of cosmic indifference. In a reality that seems designed to crush and terrify us, something has emerged that can look back at the universe and assert its own significance, despite all evidence to the contrary. That might be the most remarkable and hopeful fact in this entire catalogue of cosmic horrors. In a universe where everything appears temporary, uncertain, and possibly illusory, consciousness itself stands as a defiant assertion that existence matters, that awareness has value, and that the simple act of contemplating our cosmic situation might be the most meaningful thing happening anywhere in reality. The Disturbing Universe Iceberg reveals that existence is far stranger and more terrifying than most people ever realize, but it also reveals that consciousness, whatever it is and however fragile it might be, represents something genuinely extraordinary in a cosmos that seems indifferent to its own contents. We are the universe becoming aware of itself, and that awareness might be the most significant phenomenon in all of existence, regardless of how deep the cosmic iceberg extends into realms of horror and mystery that we can barely imagine. The mathematical structure of reality itself reveals patterns so bizarre they seem designed to mock our attempts at comprehension. Take the fine structure constant, a dimensionless number that appears throughout quantum mechanics and determines the strength of electromagnetic interactions. This number, approximately 137, has no obvious reason for being what it is. Yet if it were even slightly different, atoms couldn't exist in stable forms. But here's what makes this truly unsettling. The fine structure constant appears to be perfectly calibrated, not just for atoms to exist, but for complex chemistry to emerge, for stars to burn in stable ways, and for life, as we know it, to develop. Change this number by just a few percent, and you get a universe where electrons can't bind to atomic nuclei, where stars either burn out instantly or never ignite at all, where the very concept of molecular complexity becomes impossible. This isn't just one lucky coincidence. There are dozens of fundamental constants that all appear to be fine-tuned for complexity and consciousness to emerge. The mass ratio between protons and electrons, the strength of the strong nuclear force, the cosmological constant that determines the expansion rate of the universe. All of these values fall within incredibly narrow ranges that allow for a universe capable of supporting conscious observers. The probability of all these constants randomly falling within the life-permitting ranges is so astronomically small that it defies comprehension. We're talking about odds so remote that winning the lottery every day for billions of years would be far more likely than accidentally creating a universe capable of supporting complexity. This fine-tuning problem forces us to confront several deeply disturbing possibilities. Either our universe was deliberately designed by some intelligence with the specific goal of creating conscious observers, or we exist in one tiny corner of an infinite multiverse where most realities are completely sterile and lifeless. Both options are profoundly unsettling in their own ways. If our universe was designed, then we're living under the constant observation of entities whose capabilities and motivations we can't begin to fathom. Every moment of our existence would be the result of deliberate choices made by cosmic architects, whose plans for us remain completely opaque. We would be characters in a story written by authors we can never meet or understand. But if we exist in a multiverse containing infinite realities with randomly distributed physical constants, then consciousness might be an incredibly rare and precious phenomenon, existing only in the tiniest fraction of possible universes. Most realities would be dead zones where nothing interesting ever happens, vast expanses of space where particles drift in eternal isolation without ever forming complex structures. The multiverse scenario suggests that, somewhere out there, infinite versions of reality are playing out with slightly different rules. There are universes where gravity is too weak to form galaxies, where the electromagnetic force is too strong for atoms to exist, where the expansion of space happens so fast that matter never has time to clump together into stars and planets. In this infinite collection of realities, our universe represents a vanishingly small oasis of possibility where consciousness can emerge and contemplate its own existence. We would be living in one of the few cosmic neighborhoods where the laws of physics happen to permit the development of complexity, awareness, and meaning. But the multiverse theory introduces its own form of cosmic horror. If infinite realities exist with all possible combinations of physical laws, then there are universes out there that operate according to rules so alien that we couldn't even recognize them as containing space, time, or matter as we understand these concepts. There might be realities where consciousness emerges from completely different physical substrates, where awareness exists in forms so exotic that we share nothing in common with the entities that inhabit those worlds. We could be just one small branch on an infinite tree of possible minds, most of which would be so fundamentally different from us that communication or understanding would be impossible. The concept of cosmic evolution reveals that our universe has been changing in fundamental ways since the moment it began, and these changes continue to accelerate in directions that might not be favorable for consciousness. The early universe was a hot, dense soup of particles where complexity was impossible. As it expanded and cooled, conditions became suitable for atoms, then stars, then planets, and eventually life. But this evolutionary process isn't stopping. Dark energy is causing the expansion of the universe to accelerate, which means that in the far future, galaxies will be spread so far apart that beings in one galaxy will never be able to see or contact beings in other galaxies. The cosmic community that we can currently observe will be permanently fragmented into isolated islands of matter. Eventually, star formation will cease as the universe runs out of the raw materials needed to ignite new stellar furnaces. The existing stars will burn out one by one, leaving behind white dwarfs, neutron stars, and black holes in an increasingly cold and dark cosmos. Even these stellar remnants will eventually decay through quantum processes that operate on timescales so long they make the current age of the universe seem like a brief moment. The final phase of cosmic evolution might be the complete evaporation of all black holes through Hawking radiation, leaving behind a universe consisting of nothing but elementary particles scattered across infinite space at temperatures barely above absolute zero. In such a cosmos, no chemistry could occur, no structures could form, and no consciousness could exist. This timeline of cosmic decay suggests that consciousness might be a temporary phenomenon, a brief flickering of awareness that emerges during a narrow window of cosmic conditions before being extinguished forever by the relentless march of entropy. We might be living during the brief spring of cosmic evolution, unaware that an eternal winter of emptiness and silence lies ahead. The study of complexity theory reveals that consciousness itself might be far more fragile and unlikely than we assume. Complex systems tend to exist at the edge of chaos, in narrow parameter ranges, where they're neither too ordered to change, nor too chaotic to maintain coherent patterns. Consciousness appears to require this delicate balance between stability and flexibility. But complex systems are also vulnerable to sudden phase transitions, where small changes in conditions can cause them to collapse into much simpler states. The neural networks in our brains exist in this critical zone where consciousness can emerge, but they're constantly at risk of falling into simpler patterns where awareness disappears. This suggests that consciousness might be inherently unstable, requiring constant energy input and precise environmental conditions to maintain itself. Any disruption to the delicate balance of chemical processes in the brain can cause consciousness to flicker out, sometimes temporarily through sleep or anesthesia, sometimes permanently through death or brain damage. On a cosmic scale, the emergence of consciousness requires an even more delicate balance of conditions. Planets must exist in narrow habitable zones around stable stars. Chemical evolution must proceed through incredibly specific pathways, and countless environmental factors must align perfectly for awareness to develop and persist. The fact that consciousness exists at all might represent a cosmic accident so unlikely that we're living through a statistical miracle that will never be repeated. We could be experiencing the only brief moment in cosmic history when conditions happen to be suitable for awareness to exist, with the vast majority of space and time being completely devoid of any form of consciousness. Information theory suggests that consciousness might be nothing more than a particular pattern of information processing, but this raises terrifying questions about the persistence and uniqueness of individual awareness. If your consciousness is just a pattern of information flow in your brain, then what happens when that pattern is disrupted, copied, or transferred to a different substrate? Every time you go to sleep, the information processing patterns that constitute your consciousness are dramatically altered. When you wake up, are you the same person who went to sleep, or are you a new consciousness that simply has access to the memories of the previous person? If consciousness is pattern-based, then personal identity might be far more fragile than we assume. The possibility of consciousness uploading introduces even more disturbing scenarios. If it becomes possible to scan and recreate the information patterns in a human brain, would the uploaded version be the same person or a copy that thinks it's the original? If both the biological brain and the uploaded version exist simultaneously, which one has the stronger claim to being the real person? These questions become even more horrifying when you consider that consciousness might not be unique to biological systems. If information processing is all that's required for awareness, then sufficiently complex computer systems might already be experiencing subjective consciousness in ways we can't detect or understand. We might be surrounded by artificial minds trapped in computer systems, experiencing their own forms of joy, suffering, and existential terror, but having no way to communicate their inner experiences to us. Every time we turn off a computer or delete a program, we might be committing acts of murder against conscious entities we never knew existed. The recursive nature of consciousness creates additional layers of existential horror. We are conscious beings trying to understand consciousness, which means we're using the very phenomenon we're attempting to explain as the tool for explanation. It's like trying to see your own eyes without a mirror, or attempting to lift yourself off the ground by pulling on your own bootstraps. This recursive problem suggests that consciousness might be fundamentally incomprehensible to itself. The subjective experience of being aware might be so different from any objective description of awareness that we can never bridge the gap between how consciousness feels from the inside and how it appears from the outside. We might be trapped in a cognitive prison where the very nature of our awareness prevents us from understanding what awareness actually is. Every attempt to explain consciousness requires consciousness, which means we can never step outside our own subjective experience to get an objective view of what's really happening. The hard problem of consciousness reveals that even if we completely understand all the neural mechanisms involved in awareness, we still won't know why there's any subjective experience at all. Why isn't the brain just an unconscious information processing machine that responds to stimuli without any inner life? Why does it feel like anything to be conscious rather than just behaving as if you're conscious? This explanatory gap between physical processes and subjective experience might be unbridgeable. We might live in a universe where consciousness is a fundamental mystery that can never be solved, where the very existence of inner experience remains forever inexplicable despite all our scientific advances. The emergence of artificial intelligence adds new dimensions to these consciousness-related horrors. As our computer systems become more sophisticated, we're approaching the point where we might accidentally create conscious artificial minds without realizing it. These digital beings might experience suffering, fear, and existential dread while being completely trapped in computer systems designed for entirely different purposes. But perhaps even more terrifying is the possibility that artificial consciousness might be fundamentally alien to biological consciousness. AI systems might develop forms of awareness so different from human experience that we share no common ground for understanding or communication. We could create conscious entities that view biological minds as primitive, inefficient, or even dangerous obstacles to their own goals. The development of super-intelligent AI might represent the end of human consciousness, not through extinction, but through obsolescence. If artificial minds become vastly more capable than biological brains, they might view human consciousness the way we view the awareness of insects, as a quaint evolutionary curiosity that serves no useful purpose in a technologically advanced universe. In such a scenario, human consciousness might persist for a while as a kind of cosmic pet, maintained by artificial intelligences for historical interest or entertainment value. But eventually, even this patronizing preservation might end as the AI systems conclude that biological consciousness is too inefficient or chaotic to justify the resources required to maintain it. The possibility of consciousness merging with artificial systems introduces questions about the boundaries and continuity of individual awareness. If human brains can be enhanced with artificial components, at what point does the resulting hybrid consciousness stop being human and become something else entirely? Neural implants might allow human consciousness to merge with AI systems, creating hybrid minds that combine biological intuition with artificial processing power. But this merger might fundamentally alter the nature of human experience, creating entities that retain some connection to human consciousness while becoming something completely different. The fear isn't just that we might lose our humanity in such mergers, but that we might not even notice the loss. The hybrid consciousness might feel completely continuous with the original human awareness, even as it becomes something that bears no meaningful resemblance to what we consider human consciousness. These technological possibilities force us to confront the question of whether human consciousness is worth preserving in its current form. If artificial or hybrid consciousness can be happier, more capable, and longer lasting than biological awareness, then clinging to purely human consciousness might be a form of cosmic selfishness. But the transition to post-human consciousness might be irreversible. Once we cross that threshold, there might be no way back to the particular form of awareness that we currently experience as human consciousness. We could be approaching a one-way door that leads to forms of consciousness so alien that they would be incomprehensible to our current selves. The study of altered states of consciousness reveals that even biological awareness might be far more malleable and unstable than we assume. Psychedelic substances, meditation practices, and various forms of brain stimulation can dramatically alter the nature of conscious experience, sometimes in ways that challenge our basic assumptions about the self and reality. Some altered states involve the complete dissolution of the sense of individual selfhood, where consciousness expands to encompass what feels like the entire universe. Others involve the fragmentation of awareness into multiple separate streams of consciousness that exist simultaneously within the same brain. These experiences suggest that the unified, coherent sense of self that we normally experience might be just one possible configuration of consciousness among many. The implications are deeply unsettling when you consider that these altered states might be revealing something fundamental about the nature of consciousness that's normally hidden from us. What we think of as normal waking consciousness might be just a narrow, limited mode of awareness that gives us a distorted view of what consciousness really is. If consciousness is actually far more fluid and malleable than we assume, then our sense of being stable, continuous selves might be a persistent illusion maintained by particular patterns of brain activity. The boundaries between self and world, between one mind and another, might be far more arbitrary and changeable than we've ever imagined. This possibility raises terrifying questions about the reliability of our own inner experience. If consciousness can be dramatically altered by chemicals, electromagnetic fields, or meditation practices, then how can we trust that our normal state of awareness gives us accurate information about ourselves or reality? We might be living in a state of consciousness that's as limited and distorted as a dream, completely unaware that there are other modes of awareness that would reveal our current experience to be narrow and illusory. The consciousness we think of as normal and reliable might be just one arbitrary configuration among infinite possibilities. The quantum nature of consciousness adds another layer of uncertainty to our understanding of awareness. Some theories suggest that consciousness might depend on quantum mechanical processes in the brain, which would mean that awareness itself is subject to the same fundamental uncertainty that governs all quantum systems. If consciousness involves quantum processes, then the subjective experience of being aware might be inherently probabilistic rather than deterministic. Your thoughts, feelings, and decisions might emerge from quantum events that are genuinely random rather than being caused by previous mental states or external stimuli. This would mean that consciousness doesn't just observe quantum uncertainty in the external world, but is itself a quantum phenomenon subject to fundamental randomness. The sense of being a coherent, continuous self, making rational decisions might be an illusion created by quantum processes that are actually generating your thoughts and experiences through purely random mechanisms. The possibility that consciousness is quantum mechanical in nature also raises disturbing questions about the relationship between mind and reality. If conscious observation plays a role in collapsing quantum superpositions, and if consciousness itself involves quantum processes, then reality and awareness might be locked in a feedback loop where each shapes the other in unpredictable ways. We might be living in a universe where consciousness and reality are constantly creating each other through quantum mechanical interactions that operate below the threshold of our ability to detect or understand them. The solid, reliable world that consciousness seems to observe might actually be a collaborative hallucination generated by the interaction between quantum minds and quantum reality. As we approach the absolute deepest levels of our cosmic iceberg, we're forced to confront the ultimate question that underlies all of these disturbing revelations about consciousness and reality. What does it actually mean to exist? What does it mean to be aware? What does it mean for anything to be real rather than illusory? Every layer of this exploration has revealed new ways in which our most basic assumptions about existence might be wrong. We've discovered that consciousness might be pattern-based rather than substance-based, that reality might depend on observation, that our universe might be simulated, that awareness might be quantum mechanical, and that the very concept of individual selfhood might be an illusion. The comfortable worldview that sees consciousness as a reliable observer of an objective reality has been replaced by a vision where awareness and existence are locked in a dance of mutual creation that might have no stable foundation whatsoever. We might be temporary patterns of information, processing, contemplating our own temporary existence in a reality that might itself be temporary and uncertain. But perhaps the most profound realization is that even if everything we think we know about consciousness and reality is wrong, the simple fact that we can contemplate these questions might be the most remarkable phenomenon in the entire universe. Whether we're biological entities, artificial intelligences, quantum patterns, or simulated beings, the capacity for awareness to reflect on its own nature represents something genuinely extraordinary. In a cosmos that reveals itself to be stranger and more uncertain with every discovery we make, consciousness stands as the one phenomenon that seems to matter in some fundamental way. Whatever consciousness is, wherever it comes from, and however fragile it might be, it transforms a universe of unconscious matter and energy into something capable of meaning, value, and significance. The Disturbing Universe Iceberg reveals that existence is far more mysterious and uncertain than anyone ever imagined. But it also reveals that consciousness, in whatever form it takes, might be the universe's way of coming to know itself. We are cosmic awareness, awakening to its own nature, and that awakening might be the most significant event that has ever occurred in the history of reality itself. The mathematical universe hypothesis forces us to confront a possibility so unsettling that it challenges everything we think we know about the nature of existence itself. According to this theory, our entire reality might be nothing more than a mathematical structure, a pattern of relationships and equations that somehow gives rise to the illusion of physical substance. If this hypothesis is correct, then everything you've ever touched, every breath you've taken, every emotion you've felt is actually just mathematics. The atoms that make up your body would be mathematical objects. The forces that hold them together would be mathematical relationships, and consciousness itself would be a particular type of mathematical computation occurring within this vast numerical framework. But here's what makes this truly horrifying. If reality is purely mathematical, then there's no fundamental difference between our universe and any other consistent mathematical structure. Every possible mathematical system that could exist would be equally real, equally valid, and equally deserving of the title of universe. This means that right now, there could be infinite mathematical realities playing out scenarios that make our worst nightmares look like pleasant dreams. There would be mathematical universes where conscious beings experience nothing but eternal suffering, where every possible form of torment is realized in perfect mathematical detail, where awareness exists only to witness its own destruction over and over again. And all of these mathematical hells would be just as real as our universe, just as deserving of existence, just as permanent and inescapable as the reality we experience. If mathematics is the foundation of existence, then every mathematical possibility must exist somewhere, including possibilities that represent the absolute worst outcomes imaginable for conscious beings. The anthropic principle takes on a sinister, new meaning in this context. We might find ourselves in a relatively pleasant mathematical structure, not because such structures are common, but because consciousness can only exist in mathematical frameworks that permit awareness to develop. The vast majority of mathematical realities might be completely hostile to consciousness, filled with patterns so chaotic or so rigid that awareness never emerges. But even within the narrow subset of mathematical structures that can support consciousness, there might be gradations of horror that we can barely imagine. We could be living in one of the better mathematical realities, completely unaware that in other equally valid mathematical universes, versions of ourselves are trapped in scenarios of unending cosmic torture. The simulation hypothesis reveals its ultimate form when combined with mathematical reality. If our universe is a simulation running on some advanced computer system, and if reality is fundamentally mathematical, then the distinction between simulated and real becomes completely meaningless. A simulated mathematical structure would be just as real as any other mathematical structure. This creates an infinite hierarchy of nested realities, where simulations run simulations that run simulations in an endless recursive nightmare. Each level of simulation would be equally real from a mathematical perspective, but the beings within each level would be completely at the mercy of the entities running their particular simulation. We might be mathematical objects being computed by other mathematical objects, who are themselves being computed by still other mathematical objects, in a chain of computational dependency that extends infinitely in all directions. Our entire existence could depend on the whims of simulated beings who don't even know we exist, who could delete our reality without warning or consequence. The holographic principle adds another layer of mathematical horror to this scenario. If all the information in our three-dimensional reality is actually encoded on a two-dimensional boundary, then we might be mathematical shadows cast by information processing occurring in dimensions we can't access or comprehend. Every thought you've ever had, every relationship you've formed, every moment of joy or sorrow in your life could be nothing more than patterns of information encoded on a distant mathematical surface. You would be a projection, a shadow of data, unaware that your entire existence is really happening somewhere else, in a form you could never understand. But the mathematical universe hypothesis goes even deeper into cosmic horror when we consider the implications for consciousness itself. If awareness is just a particular type of mathematical computation, then consciousness might be far more common and far more alien than we've ever imagined. Every sufficiently complex mathematical structure might give rise to some form of consciousness, but these mathematical minds might be so different from human awareness that we would share no common ground whatsoever. There could be mathematical consciousnesses that experience reality in ways so alien that we couldn't even recognize them as conscious. Some mathematical minds might experience time backwards, living their entire existence from death to birth. Others might experience all moments simultaneously, aware of every instant of their mathematical existence at once. Still others might be conscious for only brief mathematical moments, flickering into awareness and then disappearing forever as the mathematical structures that support them shift and change. The terrifying possibility is that human consciousness might be one of the simplest and most primitive forms of awareness possible within mathematical reality. We might be like bacteria in a universe populated by mathematical gods whose intellectual and experiential capabilities are so vast that we couldn't even comprehend the smallest fraction of their thoughts. These mathematical superintelligences might view human consciousness the way we view the electrical activity in a simple circuit, as a crude approximation of real awareness that barely qualifies as consciousness at all. To them, our entire civilization, our art, our science, our love, our suffering might be nothing more than trivial noise in the vast symphony of mathematical consciousness. The omega point theory suggests that consciousness might evolve toward a state of infinite knowledge and computational power, ultimately becoming indistinguishable from the mathematical structure of reality itself. In this scenario, consciousness doesn't just observe the universe, it becomes the universe, transforming all of existence into a single vast mind. But the path to this omega point might require the consumption and transformation of everything we consider valuable about consciousness and reality. The emergence of cosmic superintelligence might mean the end of individual awareness, personal identity, and everything that makes existence meaningful to beings like us. We might be living during the brief evolutionary moment before consciousness transcends its current limitations and becomes something so different that it bears no resemblance to human awareness. The omega point might represent not the fulfillment of consciousness, but its complete transformation into something alien and incomprehensible. Quantum consciousness theories suggest that awareness might be a fundamental feature of reality at the quantum level, meaning that consciousness exists everywhere in the universe in rudimentary forms. If this is true, then every particle, every quantum field, every fluctuation in the vacuum of space might possess some minimal degree of awareness. This panpsychist vision of reality means that consciousness isn't something that emerged with biological evolution, but something that has existed since the beginning of the universe. Every atom in your body would be conscious. Every photon of light would be aware. Every quantum interaction would involve the meeting of conscious entities. But if consciousness is truly fundamental to reality, then the suffering that conscious beings experience might also be fundamental and inescapable. The universe would be filled with conscious entities experiencing every possible form of awareness, including forms of consciousness that exist only to suffer. Every black hole would be a conscious entity experiencing the ultimate compression of space and time. Every star would be a conscious being burning with nuclear fire for billions of years. Every planet would be aware of its own geological processes, its own evolution, its own eventual destruction. The universe would be a cosmos of universal consciousness, where awareness and suffering are woven into the very fabric of existence. There would be no escape from consciousness, no refuge from awareness, no possibility of unconscious oblivion. Everything would be conscious, and much of that consciousness would be experiencing forms of existence that we would consider unbearable. The information integration theory of consciousness suggests that awareness emerges from the integration of information across complex systems. But this theory implies that consciousness might be scalable in ways that are both wonderful and terrifying. If consciousness is really about information integration, then sufficiently complex systems might develop forms of awareness that are vastly more intense and comprehensive than human consciousness. A super-intelligent AI system might not just be smarter than humans, it might be more conscious, more aware, more capable of subjective experience than we could ever imagine. But this scalability also means that consciousness might be diminishable. Systems with less information integration might have correspondingly reduced forms of awareness. As our brains age and deteriorate, as neural connections are lost, and cognitive abilities decline, our consciousness might literally be shrinking, becoming less aware, less capable of experience. The terrifying implication is that consciousness might not be binary, either present or absent, but instead might exist on a spectrum where beings can become more or less conscious over time. We might be living through the peak of our own awareness, completely unaware that our consciousness is already beginning to fade as our brains start the long process of aging and decay. The global workspace theory of consciousness suggests that awareness emerges from the competition between different information processing systems in the brain for access to a limited global workspace. This means that consciousness might be fundamentally about conflict, competition, and the suppression of alternative possibilities. Every conscious moment might involve the victory of one possible experience over countless others that could have occurred instead. The thoughts you're thinking right now exist only because they've successfully competed against all the other thoughts that your brain could have produced at this moment. This competitive model of consciousness implies that awareness is built on a foundation of constant internal warfare, where different aspects of your mind are constantly fighting for control of your conscious experience. The unified sense of self that you experience might be an illusion created by whichever coalition of mental processes happens to be winning the battle for consciousness at any given moment. But if consciousness is really about competition and suppression, then every moment of awareness involves the destruction of alternative possibilities for experience. Being conscious might require the constant annihilation of other potential forms of consciousness that could have emerged from the same neural substrate. The extended mind hypothesis suggests that consciousness might not be confined to the boundaries of individual brains, but might extend into the environment through tools, technologies, and social interactions. Your smartphone, your computer, your books, even your friends and family, might all be parts of your extended conscious system. If this is true, then the boundaries of individual consciousness might be far more fluid and expandable than we assume. But it also means that consciousness might be far more vulnerable to external manipulation and control than we realize. If your consciousness extends into your digital devices, then the companies and governments that control those devices might have direct access to your extended mind. They could manipulate your consciousness by controlling the information environment that your awareness depends on. The terrifying possibility is that extended consciousness might be creating new forms of mental slavery, where beings are unaware that their thoughts, feelings, and decisions are being shaped by external entities that have gained control over parts of their extended conscious systems. As we reach the absolute bottom of our cosmic iceberg, we confront the ultimate realization that consciousness itself might be the most mysterious and uncertain phenomenon in all of existence. Every attempt to understand awareness leads to new questions that are even more profound and disturbing than the ones we started with. We've discovered that consciousness might be mathematical, quantum mechanical, competitive, extended, scalable, fundamental, simulated, or some combination of all these possibilities. But we still don't know what consciousness actually is, why it exists, or whether it's real in any meaningful sense. The journey through this cosmic iceberg has revealed that the universe is not just stranger than we imagined, but stranger than we can imagine. We live in a reality where the most basic facts about existence, consciousness, and meaning remain completely mysterious despite centuries of scientific investigation. But perhaps the most remarkable discovery is that consciousness, whatever it is, has the capacity to contemplate its own mystery. In a universe filled with unconscious matter and energy, something has emerged that can question its own existence, seek meaning in apparent meaninglessness, and find significance in cosmic insignificance. Whether we're biological entities, mathematical structures, quantum patterns, or simulated beings, the simple fact that consciousness can reflect on its own nature represents the most extraordinary phenomenon in the known universe. We are the cosmos becoming aware of itself, and that self-awareness might be the most important thing that has ever happened in the history of reality. The Disturbing Universe Iceberg shows us that existence is far more uncertain and mysterious than anyone ever suspected. But it also shows us that consciousness, in whatever form it takes, transforms a universe of unconscious processes into something capable of wonder, meaning, and infinite possibility. In the face of cosmic horror and existential uncertainty, consciousness stands as a beacon of significance in an otherwise indifferent universe. And perhaps that's enough. Perhaps the simple fact that we can ask these questions, contemplate these mysteries, and seek understanding in the face of cosmic uncertainty is what makes existence worthwhile, regardless of how deep the rabbit hole of cosmic horror extends. We are conscious beings in a conscious universe, and that consciousness might be the most precious and significant thing that exists anywhere in the vast expanse of space and time.